Theoretical mathematicians are obsessed with pristine environments. They seek out structural frameworks where equations resolve perfectly, leaving behind no fractions, infinite decimals, or remainders. This grid generates the fundamental Pell sequence, progressing through 0, 1, 2, 5, 12, and 29. Within it operates the quarter return backstep extractor, taking a trio of Pell numbers, canceling out the noise, and cleanly extracting the exact prior term. These zero residual frameworks represent absolute, predictable mathematical closure. It is a lawful system where every variable is accounted for. But altering a single structural parameter within this pristine environment forces the entire equation down a hidden, highly specific anomaly branch. Feeding the Pell integers 29, 70, and 169 into this altered pipeline bypasses normal rules, outputting the number 377. This fractures into 29 multiplied by exactly 13, the seventh entry in the Fibonacci sequence, acting as a distinct bridge between two mathematical worlds. Extracting that 13 is an intentionally engineered Diophantine puzzle, an equation designed specifically to accept only whole, integer solutions. This specific integer is a signal, underpinning a massive, multi-trillion-dollar pricing solution operating right now on Wall Street. To understand that Wall Street connection, we must leave the predictable world of whole numbers and enter the messy, unbounded realm of continuous calculus. For centuries, mathematicians navigating chaotic data relied heavily on the Taylor series. The Taylor series is a mathematical tool that uses a sequence of standard polynomials to approximate and predict the shape of complex, continuous curves. This diagram displays a Taylor polynomial actively bending to wrap itself around erratic data. But the model has a fatal flaw. When forced to evaluate sudden volatility, these truncated models violently snap, breaking down entirely and creating rigid, artificial boundaries. System theorists define this specific mathematical collapse as a not-infinity event. A not-infinity event occurs when an operation attempts to push a system beyond its natural limits, causing the coordinate framework to physically fracture. This abstract theoretical failure directly impacts the global economy. Quantitative analysts on Wall Street trading floors historically relied on these exact models to price risk and manage daily market swings. The models fail worst when analysts price exotic options. Exotic options are complex financial derivatives whose massive payouts are tied to highly erratic market histories that defy standard probability curves. Wall Street quants realized they were trapped in a Taylor cage. They were using rigid, brittle mathematical equations to predict the turbulent realities of global finance, and the models were snapping under the pressure. Escaping that mathematical cage meant throwing out the standard continuous polynomials completely. Financial engineers introduced a highly adaptive replacement algorithm to price extreme market volatility, the Swift method. Swift stands for the Shannon Wavelet inverse Fourier technique, an advanced pricing algorithm utilizing localized waves instead of rigid polynomials. This visual highlights the difference. Unlike the rigid Taylor polynomials, the Swift method deploys highly localized Shannon wavelets that gracefully navigate sudden market spikes and massive drop-offs without fracturing. Swift finally gives analysts the accuracy required to price exotic financial derivatives, entirely bypassing the not-infinity events that crippled the old mathematical cages. This brings us back to the hidden naming architecture linking the entire framework together. We have highly volatile Wall Street instruments, the exotic options, crashing against restrictive mathematical boundaries, the Taylor cage. This triptych visually lines up the narrative: the chaotic exotic markets, the broken Taylor models that failed them, and the adaptive Swift algorithm. Combine those terms with the discrete math we started with. That anomalous branch in the Pell sequence was heavily engineered by mathematicians to output the Fibonacci prime number 13. 13 is famously recognized as pop star Taylor Swift's signature, ubiquitous lucky numeral. The exotic Taylor Swift framework serves as a unifying bridge. It demonstrates that elite quantitative finance can simultaneously solve a multi-trillion-dollar structural failure while executing a perfectly engineered inside joke.